In this video, we're going to use our 2-to-1 MUX that we built last time and use it to build a 4-to-1 MUX. So let me show you how that works. So recall that a 2-to-1 MUX looks like this. I will have two inputs, x0 and x1. And I will have an output that I'm going to name y0. And I have a selector S that I'm going to place here. Actually, I'm going to call this selector S0 for reasons that will become clear. This is a 2-to-1 MUX. Now what I'm going to do is I'm going to add another 2-to-1 MUX. And it too is going to have two inputs. And these I'm going to call them x2 and x3. And it is going to have the same selector signal S0. And this output I'm going to call y1. And now I am going to feed y0 and y1 into a third 2-to-1 MUX that has selector S1, and my output is going to be Y. So in all this, I have four data inputs, four 1-bit inputs for my data. I have another 2-bit selector, and I have a single output, which is Y. So this is my whole system. And I'm going to show you why. First of all, I would like to prove to you that this in fact works. You should never take my word for anything. So let's prove that it works. And then we're going to go ahead and implement it in Verilog exactly like this, using as a building block our existing 2-to-1 MUX that we already defined in the last video. So let's do a little truth table. So what I'm going to do is have a truth table with S1 and S0. I'll show the interim signals, Y1 and Y0. And finally, my output Y. And it's not going to be a traditional truth table. I'm going to express Y1 and Y0 and Y in terms of my inputs X. So let's start with our inputs, our selectors, 1, 0, and 1, 1. And I'm doing this to convince you that, in fact, this is a 4-to-1 MUX where based on the value of S1 and S0, my output Y will be one of the four inputs X0 through X3. So let's see if in fact this is the case. So let's go step by step. So let me start with S0 over here. So I know that when S0 is 0, Y0 is going to be equal to X0 and Y1 is going to be equal to X2. I always select the first input when my selector is equal to 0. So when S0 is 0, in both these cases, here and here, I know that Y0 will be X0 and Y1 will be equal to X2. And I know that when S0 is equal to 1 over here, right? So that's this. When S0 is equal to 1 by the operation of a 2-to-1 MUX, Y0 will equal X1 and Y1 will equal X3. So Y0 will equal X1 and Y0 will equal X3. Okay, now let me look at S1. So so far I've only considered S0, but now I'm going to look at S1, which controls this MUX over here. And I know that when S1 is 0, then the output of the MUX, Y, will be equal to Y0. So let me draw that. So when S1 is 0, Y will be equal to Y0. And when S1 is equal to 1, Y will be equal to Y1. Okay, but in fact, I know that in this case over here, Y0 is simply equal to X0. And here, Y0 is equal to X1. And Y1 in this case is equal to X2, and here it's equal to X3. So what I have here is a 4-to-1 MUX such that when S1, S0 is 0, I select X0. When S1, S0 is 0, 1, I select X1. When S1, S0 are 1, 0, I select X2. And when S1, S0 are 1, 1, I select X3. So now I hope I've convinced you that in fact this configuration does implement a 4-to-1 MUX. And we're going to go ahead and implement it exactly like this in Verilog using our existing 2-to-1 MUX modules that we have already created. My 4-to-1 MUX, I'm going to add a new source, a design source, and I'm going to create a new file. I'm going to call it MUX 4-to-1 to observe the same convention as my MUX 2-to-1. And when I click finish, it'll pop up the module definition dialog box, and I'm going to keep this module name. And recall that for this MUX, I had 6 inputs and a single output. So my 6 inputs were X3, X2, X1, X0. You're probably wondering, isn't there an easier way to do this? And in fact, there is, but we will get to that later. I'm going to do S1 and S0. And finally, I will define my output Y. So far these have all been inputs, and Y is going to be my output. Okay. And that's going to create the file. Here it is over here. Okay, so in this 4-to-1 MUX file that I have, I've got my 6 inputs, X3 to X0 and S1 to S0, and my output Y. And now what I want to do is I want to pretty much implement that schematic that I showed you, where I have 3 2-to-1 MUXes, and my output of the last MUX is going to be Y, and so forth. So how I'm going to define this is I'm going to do what's called instantiation. So the first thing I'm going to do is I'm going to declare my internal wires. I'm going to define Y1 and Y0. So these are internal wires that are not inputs or top-level inputs or outputs, but they are internal to my module. And finally, I'm going to perform what is called instantiation. So what does instantiation mean? It means that I am going to, so this module, 2-to-1 MUX, it defines my 2-to-1 MUX with my two inputs, my two input bits, and my selector and my output Y. And I can place as many of those into my 4-to-1 MUX module as I want. And each one that I place is called an instantiation, an instance. So I'm creating an instance of it. In this file, I am defining it. And here in my MUX 4-to-1 file or module, I'm going to create an instance of them. So you can think of this as like, if I have an IC, I know how the IC works. I have the data sheet for the IC with all the electrical parameters and the operating characteristics. And then I can take a number of these ICs and place them on my breadboard. And this is the equivalent of as if I had created a MUX 2-to-1 IC, and now I'm placing copies of them on my breadboard. So this is sort of the equivalent of what I'm doing. So I'm going to instantiate them like so. I'm going to use the name of the module, MUX 2-to-1. And I'm going to call it, when I instantiate it, I have to think of wiring up your IC. So I have to respect the pin numbering. And the pin numbering, as we discussed, the pin numbering in a module is equivalent to the ports. So what I need to do is I need to respect the port ordering. So when I define my MUX 2-to-1 module, I defined 4 ports in the following order. My selector, X0, X1, and Y. And now when I instantiate it, I have to wire them accordingly, respecting the same port ordering. So in my first MUX, my selector S is actually S0. My X0 was in fact X0. And I'm just going to double check the ordering by looking here. So yes, so my second port is in fact supposed to be X0. So coming back here, so X0, X1, and recall that according to my 4-to-1 schematic, the output of this MUX is going to be Y0. I left out one thing. I have to assign it a name. So this is the name of the module that I want to instantiate, and I'm going to give that module a name. I don't think I have to, but I'm going to do it anyway. So I'm going to call it MUX0, like so. And now I'm going to instantiate my second MUX, which I'm going to call MUX1. But what is it? It's a 2-to-1 MUX. So I start the statement with the name of the module, and then I give my instance a friendly name. So it's like when I place it on the breadboard, I give this particular IC that I'm placing on the breadboard its own name that distinguishes it from the other 2-to-1 MUXes on my breadboard. So that's the equivalent thing that I'm doing here. And for my second MUX, my input is, my selector is also X0, but my first data input now is X2, and my second one is X3, and my output now is Y1. And I terminate with a semicolon. And notice how careful I am that every opening parentheses has a matching end parentheses, and also that I respect the fact that I need a terminating semicolon at the end of each statement. Okay, next, I'm going to declare my third MUX like so. MUX 2-to-1, MUX 2, and this selector is S1, and the two inputs are Y0 and Y1, and the output is simply Y. And that's it. I have wired it up now, but I am not yet done. So what I want to do is notice in the design sources, Vivado is smart and it took care of it for me. But notice what it's done here. So now if I go look at my design sources window, I noticed that the MUX 4 to 1 is bolded, and that is what's called my top modules. My top module is my top level module that the input and output ports of my top level module are mapped directly to the input and output pins of my basis board. Whereas that is no longer the case for my MUX 2 to 1 modules. So my MUX 2 to 1 has ports, but they are not top level ports. In other words, they are not directly mapped to the basis board ports. So in fact, I have, and I see my three instances, my three MUX 2 to 1 instances over here. I've instantiated them inside this MUX 4 to 1. So again, I know that the bolded file here actually corresponds to what's called the top module, which is the module whose input and output ports are directly mapped to the inputs and output pins of my basis board. Now, in order to, there's still one other thing that I have to do in order to fix this, in order to do this properly, to map my top level ports to my basis board pins, and that is the constraints files. That is actually the job of the constraints file. So, so notice here that I have my selector S. Now, my top module now no longer has a signal, a top level port called S. So it's either S1 or S0. So I'm going to have to switch things around quite a bit in my master file. So I think what I'm going to do is let's leave the rightmost four switches for X3, X2, X1, and X0, and we will leave the two switches to the left of those as the selector. And I don't have to do anything to my LEDs because I still have only a single output and it is still called Y. So that should work. I want to now take a look at my elaborated design. And this should look quite a bit different. And actually, if I look at my elaborated design now, I can see that I now have, it basically looks pretty much exactly how, I'm going to just zoom to fit. It looks exactly how I had it in my schematic earlier. So I've got these two muxes that have as selector S, S0, and this MUX has X0 and X1 as inputs, and this one has X2 and X3 as inputs. They each have an output that is wired into the X inputs of this third MUX, and that selector S is mapped to my input switch S1, and the output is mapped directly to Y, which is my LED. And the other thing that I can do is I can expand these to see, this is my original MUX 2 to 1 configuration. So I can expand it and collapse it, and you'll see that in fact what's inside them is all the same. So these are what are called instances. These are the three MUX 2 to 1 instances that I created in my 4 to 1 MUX module, and the process of doing that is called instantiation. So I want to go ahead and take a look. I am going to take a look at my, I'm going to re-synthesize and re-implement, and then I'm going to take a look at my project summary. And as soon as that is completed, I am going to scroll down to look at my utilization. All right, so my synthesis and implementation are finished, I can go take a look at my reports. But actually, I am going to scroll down in the project manager and take a look at my utilization. So now my IO has crept up, but my LUT utilization is still pretty low. So I'm just going to look directly at post implementation. And I see that I'm still, despite all this, I'm still only using a single LUT, but now I'm using 7 IO, which makes sense, right? So I have 4 X inputs, 2 selector inputs, and 1 Y output. So, so this tracks with what I know.
So program my basis board, I can tell again because the dumb LED is lit. And these 4 switches here are my X inputs to my 4-to-1 MUX, and these 2 bits are the selector. So when the selector is at 0, 0, which it is currently, then the output should follow X0, which is this. And in fact, it does. See, and it doesn't follow any of the others. However, if I move the selector now to 0, 1, then what happens? Well, now moving X0 has no effect, but moving X1 does. So my LED follows whatever the value of X1 is. Now I'm going to try the 3rd position, so 1, 0. So my selector is at 1, 0. That means that it's X3 that is going to direct the output. So that is in fact the case. And moving the other switches has no effect, just like I would expect. And finally, moving both switches to the 1, 1 position. So these are the selector switches, move to the 1, 1 position. And so none of the other switches should have an effect on the output except this one. And in fact, that's what I see.